Haim. Thanks, Arnie. She's a senior pediatric neurosurgeon at Mass General Hospital, and she's a distinguished professor of neurosurgery at Harvard Medical School. Her neuroscience research investigates a wide range of aspects of brain function. She has a long-standing interest in the relationship between brain and behavior and in environmental issues. She's a faculty associate of Harvard University's Center for the Environment, and her book on this work, Minding the Climate, was awarded the Sustainability Book of the Year in 2023 by Project Syndicate. And the talk she's giving us today is Climate Change, the Brain, and the Next 100 Years. She's going to discuss how knowledge of brain evolution and reward functions can help us understand why climate change is such a challenging problem for us to recognize and solve. As we know, our planet and our species will experience major changes during the next century with threats we have never faced before. What can we do, and how does understanding the tasks the human brain evolved to perform, what we do well, what is more difficult? How will that help us choose the best actions that will make a real difference? So before we start, I just want to remind everybody to stay on mute. Tina said it's helpful for her if people are visible on screen. She kind of can see how people are reacting. It helps her present, but it's not a requirement. It's just a request. And she's going to talk for 45 to 50 minutes, and then we'll have a Q&A. You can put your questions in the chat, or if you raise your hand, please do it electronically so I can see it quickly. And she's really welcoming all kinds of questions. If you want evidence for something she's saying, if you have other ideas you want to share, if you want to know how to apply these principles, or you've had some experience with what works and what doesn't, how is this going to help us approach our fellow humans to actually make change? So I'm really happy to turn this over to Tina and excited to hear what you have to say.
Terrific. Thank you, Amy. And thank you all for being here. What a fabulous group. You folks are just terrific. That's right. I like that. I'm going to share my screen and start with slides. Okay, now comes the obligatory. Can everybody see that? Arnie, give me a thumbs up. Can you see it? Good. And Amy? Okay, great. Okay, good. Well, I have to try to get rid of the top because I can never see the top of the screen. Let's see if I can do that. Well, that's always an issue. All right, hopefully I'll be able to see the titles of the slides. So what we're going to cover here is one person, my exploration of the intersection of how the brain is designed to function, and it's designed to function that way because of evolution, and this particular problem. And the focus is really not on short term. It's really over the challenges that we're going to face over the next, I'm for arbitrary reasons, I'm saying the next 100 years, and whether it's really 100 or not, I don't know. But the point is, this is our crucial set of decades coming up. And I want to talk about these three overlapping curves that are all problems at the same time. Now, everybody here knows that climate change is our existential crisis. I don't have to talk you folks into it, thank heavens. And so the top curve here is the temperature curve from the Intergovernmental Panel on Climate Change. You see a lot of curves like this that are carbon dioxide in parts per million, but this is one that they put together, which is actually the temperature change in degrees centigrade on your y-axis and time on the x-axis. So you see where 2050 and 2100 are at the bottom. And of course, these different pathways take into account socioeconomics and other elements to try to predict what this temperature curve is going to look like over that 100 years, 75 to 100 years, depending on what we do. So you've all seen this. This is what scares us. This is what we're trying to prevent. We're trying to stay in that blue zone at the bottom and trying to stay out of that red zone at the top. But unfortunately, we're not doing that great a job with it. Below that is another curve that overlaps in time. So all three of these curves are lined up along the meridian of the meridian of the graphs, but the time scale is not equal because it would stretch or compress along the horizontal axis. But what you see here is that the peak of human population is predicted to happen in about used to be thought 2060. Now people have pushed it back to maybe 2085 in this particular graph. This comes from population expert Dean Spears at University of Texas at Austin. And the black line is what has happened so far. The little circle there on the left side of that sharp curve is 2022 when we were at 8 billion people. We're almost up to 8.5 now. And the population is predicted to peak. And then, according to Dean Spears and many others, but not everybody, the prediction is that the population is going to plummet and it's going to decline almost as fast as it went up. But those different curves on the right-hand side of that curve, those different lines, are kind of like the ones in the IPCC curve above, which is kind of depending on what happens, these curves could be a little bit different. Now, the third curve at the bottom of the left-hand side of your screen is the one that most people don't think about much, but I think about a lot because I'm a brain-oriented person. And this is a logarithmic scale that represents the pace of change. This happens to represent Moore's law, and Moore's law is an example of the pace of technologic change in the acceleration of the capacity of semiconductors. It's sort of obscure, but it is lined up to be at the same time down the center of those three graphs, where the pace of change, this is technology, but the pace of change in your daily life reflects this kind of scientific and technologic change. So a lot of change is linear, but in our modern world, because science and technology build on themselves and build on each other, that sort of change accelerates not at a linear, but at an exponential rate. And that's what this is describing, because even though it looks like those dots are along a line, it's a logarithmic scale. So it's actually exponential. So for every bit of movement on the x-axis, it goes up by a scale of 10-fold on the y-axis. And this is relevant because I think it helps explain what some of our problem is with the whole issue of climate change and, frankly, with this election that we just had. So our challenge on the right-hand side of your screen is we have to get over the humps of these three curves. Now, the bottom curve doesn't have a hump, although there are some people who predict that as population falls, the pace of change may fall as well, because the pace of change is driven by human invention. The wild card there, and we can talk about this during the discussion because I'm not going to talk about it again during the slides, is that AI may keep that logarithmic scale going, even if the human population comes down. And in fact, it may accelerate it, which is one of the big unknowns about, the next 100 years. But to do all this, what I'd like you to think about, and I'd love to hear your thoughts when we have time for discussion, is what happens? I don't know that you can see my pointer. Amy, can you see my pointer squiggling around
Yes,
here? You can.
I can.
Okay, great.
Mhm.
So the climate movement, I think, has not done a terrific, careful job giving people a vision for what it's going to look like over here, what it's going to look like over here. This one doesn't have a peak to it, so I can't really talk about that. But even on these two curves, population and climate change, what is it going to look like on the other side? Because in order to change human behavior, one of the principles is most often you need a vision of what you're working towards. So you think about times in history where big mobilizations of behavior change happened. And in fewer people's lifetimes now, but maybe some of yours, either directly or indirectly through your parents or your upbringing, World War II, when there was rationing, when women entered the workforce, when all kinds of social changes happened, there was a vision for why people were doing it. And there was a lot of quick behavior change, but it was all because there was a common idea of what the goal was. And one of the problems that we've had here is you can see utopian drawings of beautiful green cities and so on. So there's a little of that, but we have not been consistent in that, and it's so far along. World War II, it was within years that people had a vision things would happen. It's much harder for us, for reasons we'll get to think about 50 years, 100 years down the line. But there are things that can be done to help that along. Okay, so let's just briefly cover what we're going to cover in this talk. And I am warning anybody that's really hates gory pictures. There will be a few pictures of surgery, since I'm a neurosurgeon and they are used to illustrate points. But if you're grossed out by what you think is gory, I don't think it's gory, but I'll try to warn you. Here's one, and there are a few more, but nothing too bad. The brain is not gory; it's beautiful, frankly. But just to let you know. Okay, so the overview will be not necessary for this group. We'll talk briefly about some of the main points of climate change and environmental decline, and then we're going to talk about the brain. For what tasks did our brains evolve? And what is the role of the so-called reward system? What is it? What's its role? How did it evolve? And how does it affect decision-making even now? Then we're going to talk briefly about the 21st century brain. Why has consumption in particular, which drives in large part our climate change crisis, why has it accelerated? And what does that really mean? And then what behaviors matter the most, that contribute the most to climate change? What other big trends are happening at the same time? We just covered some of those. Then if the brain evolved and it has a certain structure for decision making, it has this reward system that it picked up along the way during evolution, how changeable is it? Are we quote unquote hardwired so we can't change, like it's hopeless, or are we changeable? So we'll talk about what are the facts about how changeable the brain is in how it makes decisions. And then finally, we'll try to pull it together for how does this information help us, especially in planning for the future and in planning our own advocacy. So here's a gory brain picture. Close your eyes if you don't like it. This is just to say I am not a climate expert. This is what I have done for the past 35 years. About 2 years ago, I stopped doing actual human surgery. I still do some research surgery. I still see patients. I still take care of acute problems. But I could not do my climate work and take direct responsibility for patients in the perioperative process. So I've stopped that. Plus, I'm at an age where I think it's reasonable to transition your career to something not with surgery. But the point I'm making with this slide is this is what I've been doing for all these years. A lot of what I am talking about comes from this experience, being thoroughly immersed in how the brain works, how it develops, and how it functions and has dysfunction. And so one of the problems with this issue of climate change is, I'm going to just try one little thing here to see if I can get rid of that top thing. No, I'm sorry. I'm trying to get rid of it's covering my slides at the top. Anybody know how to do it? Show video panel. All right. Well, I pushed a button. I hope that didn't change anything. Oh, I know what happened. I lost all of you.
Are you trying to get rid of the Zoom participants in that window?
No, I'm trying to get rid of the controls at the top because it blocks the top of the slide. Yeah. And I'm not sure.
I think you should be able to put your mouse on it and move that whole bar. Does that work?
Oh yeah, I can put it at the bottom. Much better. It does move with the mouse. Thank you. Okay, good. Because otherwise I don't know what you're seeing. So that's better. Thank you. This is a brand new computer. I just got it this week. So I haven't quite learned all the glitches yet. Okay, so some of the conflicts that we encounter as human beings is the conflict of the prioritization of the immediate, of something that is here and now versus something that's far away. And we perceive the near and here and now as our problem and the far away either in time or geography as somebody else's problem. So this is just an example of, again, my patients and surgery and like, I'll do everything for that kid at that moment. It's so obvious. It's very rewarding too. Whereas it's much easier to think that something else is somebody else's shift. And this is not just me, obviously. This is, you can call it human nature, but I'm going to talk about that this comes from how the brain is designed to act. And I don't need to tell anyone in this room what this curve is. This is carbon dioxide in parts per million. This is 800,000 years ago. It's never been below 300 parts per million until the industrial era, when it skyrocketed. And it's funny that this is such an obvious graph, right? It's like, here's the problem. But if you don't like understand how to read a graph like this, or you don't trust science, or you don't trust your information, or you trust disinformation, this graph that is so alarming to all of you can be kind of ignored. Well, I don't think it's that big a deal, or whatever. In the medical field that I work in, and some of you may work in, the Lancet Countdown, which is basically a series of reports that come out every year about climate change and health. In 2021, they said we are at, a real crisis. This is a code red. We are in big trouble for a healthy future. And so that and other movements started to spur the health professions to start taking this seriously. Before that, and before, more and more things affected the health professions, physicians, by and large, felt like, look, I'm saving lives here. Like, climate change, not my shift, not my problem. It's somebody else's problem. I'm not a policymaker. That's not what I chose for my career. Now it is changing, though maybe not as fast as everybody would like. So let's stand back. It's so easy to judge clinicians and physicians or other people who don't see this as a serious problem or don't think it's their shift. It's very easy to say, what's wrong with you? Like, why don't you get it? But I tried to approach this with a different sort of arm's length approach, to ask the question of, what is it about the way our brains evolved and are designed that makes it so hard for us to change behaviors that are destroying our planet? And then once we understand that, how changeable are we, and how changeable is this tendency? Now, I'm going to make an aside here, because one of the things that I've heard a lot of pushback on is, this is not an individual problem. It's not about individuals. This is a collective action problem. Like, this is about governments and businesses and CEOs. Like, it's not about me as an individual. Like, don't even talk to us at that level. In fact, I've gotten pushback that, the fossil fuel industry would love it if people think it's all about them and it's their behavior, because it takes the pressure off them and they're the ones that have to change. So even that has been a politicized argument about individual versus collective action. But what I would say in response to that is that an individual, when you talk about individuals and that decisions are made in your brain, you're not just talking about an individual's sphere of influence in your own life. If you're the CEO of a company, if you're a person in an advocacy group, if you're the head of a university, if you're a policymaker, your decisions can have an impact in multiple spheres, not just your own domestic sphere of influence, but the companies you lead, the institutions you're part of, the political enterprises that you advocate in, how you communicate, the media, advocacy movements, and so on. So just because it happens, just because what we're talking about is at the level of the brain, it doesn't mean that it only applies to your individual personal lifestyle decisions. It means that even if you're the CEO of a company that is pushing back on climate change action, your mind is changed in the same way as everyone else's. So what did I do to try to answer this question? I won't say I have all the answers. And as nice as Amy was to say, you can ask me questions because I'll, with the implication I'll know the answer. I don't know the answer. I'm scratching the surface here. But I did what one of the perks of being in academics, even in academic medical practice, is that you can do that thing about take a sabbatical. So in 2015 to 2016, I took a year off and I went back to school, to the Radcliffe Institute at Harvard. And I got a bunch of students to work with me and do some of the background work. And we looked into this question. And that's what became this book, Minding the Climate. At the time that I started the project, I was looking at this very literally, the neurobiology of sustainable behavior. And what we came up with, my students and I, were these bottom line principles. And so now you don't have to even look at the book, but these are the basic ones. We're lacking the neural equipment to perceive CO2 and its consequences. So during evolutionary time, you and creatures on whose prototypes you evolved, you developed the ability to see color. Even if you're colorblind, you still see some color. To hear frequencies like a child crying, somebody yelling an alarm, all kinds of things you can hear. Not every frequency there is, but the ones that were most important to human survival. You can touch and manipulate things. You have great sensation, especially in things that you need the most. So you developed all kinds of things, but there was no need to develop CO2 sensors. CO2 was pretty constant during our evolutionary history, and it was not something that you needed as an alarm. So during most of your lifetimes, the CO2 level in the atmosphere has almost doubled, not quite, and you can't tell it. When you go outside, you don't know what the CO2 level is. And so the point is, when you're trying to convince people about a problem that they cannot directly perceive, it's a challenge, because if it were ammonia that were increasing in the atmosphere and it made their eyes run, they'd say, oh yeah, we got a problem, but they can't perceive CO2. So that's one thing to keep in mind, and it's easy to forget that. Another basic conclusion that we came to is that pro-environmental behavior just isn't very rewarding. It just isn't that much fun. So we'll get into that in a moment. Oh, I love that cat's tail there going across the screen. That's great. Thank you for showing us that. And then pro-environmental decisions won't feel like other decisions. They just don't feel the same as decisions that you have counted on your own instincts to help you with. These are going to be different. So we'll go over a little bit about why that is. So let's talk about what we mean by reward. When we use the word reward in neurobiology, we're not talking about reward like you get extra points if you use your credit card, towards an airplane trip or something. Reward in this sense, in this context, is your brain's way of teaching you what you need to survive. That's what it's designed for. And we'll give you some examples here. How we know about this is gone over in some detail in the book. It's the densest and most difficult chapter to read. So if anybody tries to read this book, skim chapter 2. It's kind of dense, and I tell people just kind of skim it, because I find it a really, really interesting story about how we got from things like lesions. You can see that's a famous picture of Phineas Gage. He was a railroad worker that a tamping iron went off. This is in the 1800s, and it went right through his skull, as you can see there. That's his actual skull. And he had a major change in personality. He survived miraculously, because this was before antibiotics were around. But he had a change in personality that has to do with what was rewarding and how he made decisions. But since that time, we've gotten much more sophisticated. We can do single neuron recording. We can use functional MRI to look at the reward system, deep brain stimulation, and so on. So this circuitry has been worked out really in quite amazing detail. And to me, it's a fascinating story. We got big clues from Parkinson's disease and how treatments of Parkinson's disease mess up people's reward circuitry in certain ways. That's how we learned about some of the neurotransmitters involved, and so on. So to me, it was an interesting historical enterprise. But you can go way, way back to very early organisms. So what are the first organisms on the earth? And we'll go over this again in a moment. Single cell organisms, these happen to be E. coli. That's what, gives you the outbreaks of food poisoning, or you can't go swimming because you got E. coli in your beach water. But an E. coli bacteria can swim towards sugar and away from ammonia. So it's making a decision about whether to go left or right based on not having a brain. All it's got is a single cell. And the basic principle that it uses is that it evolved over time through trial and error, a cell surface that had certain molecules on it that changed shape when it encountered something positive for its survival, like sugar, or something toxic to its survival, like ammonia. And when those molecules change shape over time, over millions of years of evolution, these little flagellae, these little tails, would change their direction that they were wiggling in based on this conformational change on the surface of the organism. That's how it works. It's stuff, chemicals on the surface that change shape when they encounter something. That's the basic principle of biology, and that's the basic underpinnings of how everything works. It's not magic. Your brain didn't come down like a computer wrapped in a box, like somebody designed this. It evolved for particular reasons and under particular pressures. So when we get to C. elegans, C. elegans has a nervous system. It has actual neurons, nerve cells. It has actual neurotransmitters, the same ones that work for us. And then when we get up to aplysia, this is the giant sea slug, studied because the neurons are very large, so they were easy to study. And C. elegans, in that organism, it was shown that the reward system is tied to learning. So when C. elegans happens to encounter and swallow something nutritious, the reward system reinforces that behavior that happened right as it was getting this nutrition, and says, do that again. And it reinforced that circuitry. What was it doing? Teaching the animal what it needs to know to survive. That's the point of having a reward system. Now, when you get up to, multicellular mammalian organisms, now we're talking animals with a lot of, and this time frame up top, but you'll understand in a minute. The mouse and rat have 70 million, 200 million neurons. C. elegans has 302, I think. And there are now more options, more decisions, and more learning. So they have to figure out, what do I eat? Where do I go? How do I get out of a storm? How do I choose a mate? What do I do when I raise a litter? What do I do when it's really cold out? So many decisions, so many things. And so their reward systems are very sophisticated. Now, one of the things that was learned from rodent studies was this principle that applies to humans. Your reward system is tuned to small, unexpected, variable rewards. So imagine you're a prehistoric human and you're walking through the forest and you're hot and you're tired and you're miserable and you just want something to eat, and you come across this patch of berries. And just like when you go hiking, and I suspect many of you are outdoor people who go hiking, you know how at the end of a long hike and you take out your like dehydrated food and you cook it up over the campfire or whatever, and it's like the best thing you ever ate? Same idea, right? The point is that the early humans, just like the rodent precursors, we needed to learn what circumstances you could find berries. What did the landscape look like? What were the shape of the leaves? What was the sunlight? And that way, next time you were walking through the forest, you might be drawn to look for something that would help you survive. You learned those associations. You didn't think about it consciously and say, oh, berries are in this place. This happens this happens unconsciously. That's how the reward system works. You're not even aware of it. And next time you'll say, I just had a hunch. What's that hunch? That hunch is your reward system and your learning, collaborating to make this job easier and increase your chances of survival. Now we get to humans. And again, the time frame you'll see in a moment. Now, it's amazing. I'm going to go back. Let's go to 70 million, 200 million neurons. The human brain, 86 billion neurons. I mean, it's just amazing how big it is. Each of those neurons has an average of 10,000 connections with other neurons. And this is a picture of the human reward system. I had to get an artist to do this because there wasn't anything that really put all the parts together in a single image that I could publish. But it's a really fascinating, complicated, incredible invention of biology. So if you're interested, there's more detail about it. Now, here's where the time comes in. I was trying to understand in my own head when all this happened. And why is that important? Because I was trying to understand, how does when all this brain evolution and the reward system and how we make our decisions, when did that happen compared to climate change? So the students helped me with this, and we decided I wanted something that showed a walk. And so they came up with a walk across the United States. This is time zero when the Earth forms. And they wanted the end point, which is now, to be the center of Times Square. I would have picked the Atlantic Ocean, go from Pacific to Atlantic. They wanted the center of Times Square. That's fine. They were college students. And so I want to give you a time frame. Up here is how the brain evolved and the reward system. And this tells you when different major events happen. This walk by Google Walk Time would take you 40 days. I know, funny, huh? Kind of like biblical, but it would take you 40 days if you never stopped. Okay, so Earth starts about 4.5 billion years ago. The first single cell organisms happen in Salt Lake City in Utah. This is, around here is when those E. coli got going. You get multicellular organisms like C. elegans, that's around here in Iowa City. You don't get to mammals till Scranton, Pennsylvania, and you don't get to primates until Morristown, New Jersey. Now we have to, and this is the corresponding nervous system and reward system. Now we have to blow it up because we're getting really concentrated. So we're getting close to Times Square now. This is now, there's the present, but this is to scale. I want to again show you that carbon dioxide curve. And here's where the carbon dioxide was here, and here's where it goes up. Now we're going to blow that up as well. This is your last footstep. And the Anthropocene, when climate change happens, doesn't occur until your last footstep of your 40-day walk and your big toe only hits the ground. That's the Anthropocene. All right. So the point of this illustration is your brain and how you make decisions, it evolved back here. Not just, it didn't like come full sprung when primates came around. It was built on the evolution and all the principles of how it operates and how molecules change conformation and all of that way back here, based on what the world was like back then. Okay. So it should not be surprising that our brains, we know how to make decisions. We know how to solve problems. But this particular problem was nothing that we ever were stressed by during our evolutionary history. And in fact, there's way, way more before now that determines how we behave. So what influences our decisions? So how does it work? Well, our brain weighs choices second to second, and it makes what is called in the neural computational world.
Hi,
Oh, that was good. Somebody's
remind everybody to thank you. Okay.
But it sounds like somebody got to see somebody very, very dear to them. So that's good. Okay. So our brain weighs choices second to second. It makes something called utility calculations. These are not mostly conscious. This happens under your radar for consciousness. The calculations that you make depend on your heredity. They depend on your life experience, and they depend on your immediate circumstances. They are largely, but not exclusively, mediated by dopamine. You've heard a lot about the dopamine, surge for getting an Amazon purchase and so on. But the bottom line is we do have general tendencies, but we also are incredibly flexible by design. And this was something I had to learn during my sabbatical and since then, like how flexible are we? These illustrations these are actual mouse brains, but they're showing real time just the complexity. All those little lines and dots are individual neurons. This happens to be in a very small part of the mouse brain, but it's a beautiful process. But the point of it is how many things are happening at once. And this is just a mouse brain. In your brain, millions and millions of things are happening every second, including now as you're listening to this talk. So our brains evolved back in that, the center of the United States in that time walk. They evolved for survival. And the squirrel didn't figure out, but, it wasn't like, oh, I think I'll do this. The behavioral instincts of the squirrel, evolution pushed them to let the squirrel learn how to store nuts. And that's how it gets through the winter. And that was for survival. Early humans figured out how to preserve food for the winter, how to make shelter, how to make clothing, how to domesticate animals, how to grind grain and make things out of it. So all of these things, and having more of it, having more food, more shelter, more clothing, all of those things helped those particular humans who figured it out to survive better. So the general principle was the more you have, the more you do, the more you get, the better off you're going to be, the more you're going to survive. And that was true up until now. Because now, the more you eat of stuff like this, that's very satisfying. Why? Because we evolved to love fat, sugar, and salt. These were things that were rare. And so just like those berries in the berry patch, when you got sugar, it was a big deal. And if you didn't like it, you were not going to survive compared to somebody who ate a lot of it. Likewise for fat, likewise for, certain kinds of protein, likewise for salt. If you didn't have a reward system that said, if you get this, eat as much as you can, you wouldn't survive compared to somebody else, and your genes would not be carried on. So the problem is we didn't really need to develop breaks because scarcity was more of a problem than excess. So evolution did not say, ooh, you've had too much of that, stop. Likewise, with stuff. I always hesitate when I show this picture that someday this is going to be somebody in my audience's house. Is this anybody's? If this is your house, I apologize. No offense. But does anybody, I mean, seriously, does anybody need a house like that? No. I don't care if you have 10 kids, you still don't need a house like that. And so what's happening is this lack of breaks that evolution did not give us is what's now leading to a contrary to survival occurrence with climate change, and also the other waste products and land utilization and all the other human influences that are destroying our planet. Now, to think about, just sort of as a little exercise, to think about what we mean by the reward system. I just want you to do a little thought exercise, which is when you're thinking about a new car, just ask yourself, is it more fun? And again, I know I'm speaking to an audience that really, really cares about climate change and the environment, but just as an exercise, is it more fun to think about, I need a new car, what make and model am I going to get? What color, what style? Or is it more fun to think about environmental impact of that car? Now, I'm not saying what's more righteous, what's more correct, what makes you feel like a better person, but what's more fun? So for most people, this audience may be an exception, but for most people, it's much more fun to think about what the car looks like and how it drives than it is to think about the environment. It's just more fun. Likewise, when you think about what's more fun, decorating your house, we just went through Halloween. Is that more fun, or is putting attic insulation more fun? And again, I'm not saying what's the better thing to do, what makes you feel like less anxious about climate change, but what's more fun? So fun, in a way, is the embodiment of your reward system working. So I would say that for this audience, the things on the right might be more satisfying for you, but for most people, the things on the left are more fun and more rewarding. You all know some of this, but I had to learn it, so I'll share it with you in case some of you are where I was. I doubt it with this audience, but there's a lot of argument about, well, what about China? China's the problem, not us. As you all know, the US is the biggest contributor to the total CO2 increase in the atmosphere because we've been at it the longest. And because CO2 lasts hundreds to 1,000 or more years, China is, it's up there. We put it up there and it's still up there for all of our post-industrial period. China is now the biggest emitter per year, not per capita, because they have such a larger population. Now, I wanted to know, because I get this question a lot and I had it of myself, how much of the excess carbon, how much of our emissions in the US, in industrialized, wealthy countries like ours, comes from things I do in my own life, and how much comes from things I can't control? And I read a lot about this, and there are different ways people draw the circle about what's your individual responsibility and so forth. But for just discussion purposes, it comes out on average, if you put all the different analyses together, about half comes from our individual sort of domestic household choices, and about half of the extra CO2 comes from companies, industries, and institutions that we as individuals may not control. The US per capita, now it's a little bit less because of a shift away from coal, but we're somewhere around 18 or 20, let's use 20 as a round number, tons of CO2 per person per year in the US and in other high industrialized countries. The world average is about 5 tons per person per year. If we wanted to keep within 1.5 degrees, which as you've probably seen in the news, we may have passed already, we have to get down to 2.1 tons per person per year in the, around the world. So that is a huge decrement for people in high emitting countries like ours. And it has to do with what we eat, how we get around, and other way, how we get our energy largely. So I wanted to know, when I went on this exploration, which behaviors mattered the most as an individual. And I know you all know you can type in carbon calculator to Google and you can find your own individual carbon footprint and carbon profile. But for most people in the US, maybe not you, because you folks really care about this and you probably have altered your behavior, but for most people, transportation and changing to a fuel efficient or electric car or going car free is the number one thing that they can do in their individual lives. Again, in high income countries. moving to a plant-based diet. You don't have to get rid of every bit of meat, but largely going towards plant-based. That's the other big thing that most people in the US can do. Home energy efficiency is on the top 5 list. And one less airplane trip per year. This is tricky for people who are maybe in their retirement years and they want to travel and they've looked forward to traveling forever. But one transatlantic flight or one flight to the West Coast and back uses up about 2 tons per person per year. That's like your whole year's allotment. So that's a big one. And I have started to take that very seriously when I give talks. And then population size is another one. That's a controversial topic. I won't get into it, but we can talk about it more during discussion. So what I would ask you about these big top 5 is changing this? Is it easy or difficult? And is it rewarding? Is it rewarding to move to a plant-based diet? Again, maybe intellectually, but how about that sort of exercise of, is this fun? Like, is it something you say, oh boy, now I get to change to a plant-based diet? Or do you say, I know I need to go to a plant-based diet? You can make it rewarding by saying, I'm going to have the best herbs and I'm going to make the coolest things and I'm going to compete with the other people in my organization to like have the best vegetarian meals. Like, okay, you can take on a competitive edge, make it more rewarding. But for most people, it feels like giving it feels like giving something that they like up for most people. Transportation, public transportation, it's like, we'll get into this more in a moment. There's another problem with pro-environmental behavior change. Getting more, acquiring, while I've said it's a big reward, that more, it's not the only one. There are other ones. And one of the really big ones in your reward system is what's called agency. This is cause and effect. I do something happens, I can feel satisfied. When we were hunter-gatherers, you got your food, you went out and you gathered, you got shellfish, you went fishing, whatever, you hunted, you had an immediate reward and you shared it with your whole family, your community. I mean, that living is difficult, but very good for agency, for the reward of agency. If you lived in, pre-modern Ireland and you made a shelter, that happens to be an Irish indigenous shelter, it was pretty satisfying. You put it together, your community helped you, you had a shelter, like agency. If you chipped a stone tool, like in the right-hand side, and now if you do surgery, like a kid has a problem, you do something and the kid is fixed. Immediate agency, very rewarding, very satisfying. If you bike to work in a city in December in Boston, like, okay, it's good for climate change, but it isn't any more fun or rewarding and doesn't give you agency. You don't say, oh, I'm biking to work. I can see that the CO2 in the atmosphere went down because I did that. There's no immediate effect. And the new way may be less comfortable and more dangerous. So not much agency, not much immediate reward. And in addition, contemporary life in our wealthy countries has accelerated consumption way beyond what we need. So part of the problem is that there is ease of access for consumption with online shopping and so forth, with even, stores that you go to Home Depot, it's like, do we need all those choices? It's quite amazing. Or a grocery store, you get an immediate reward. Purchasing and waste happen in private. In hunter-gatherer societies, everybody knew what you took and everybody knew what you threw out. And now it's all done where nobody can give you any social input or limits. Advertising, market research is amazing. When I did my sabbatical and did research for the book, I found out that there were about 15 different journals of consumer behavior. And they published article after article about how to convince people to buy stuff. It was quite amazing how detailed and how scientific that marketing research is. And so people that want to sell you something know how to do it very well. Age segregation is one that we can talk about more, but now that, in hunter-gatherer days, I'm not saying life was better then, but ages were mixed. You became an adult as soon as you could take on adult tasks. And you were always around people of various ages, where the social structure was such that you were eldered by your, people in your community. Now, school kids are with people of their own age. They have a super peer effect that we can talk about that accelerates consumption. And they also have a non-evolutionary reward schedule. Remember, we talked about small, intermittent, surprising rewards. That has been thrown on its head. So we don't have those kinds of rewards the way we did. So now that we know all that, how malleable are we? Can we change? So I didn't know the answer to this, but I was relieved to find that it turns out that the data suggests that your reward system is both malleable and gullible. And when I say gullible, I'm not talking about, I'll sell you land in Arizona, blah, blah, blah. Gullible means, in the neurologic sense, that we are, on average, predisposed to believe what we are told by authority figures. And you can imagine why that would be evolutionarily adaptive, because if you're about to step on a hornet's nest or a red ant nest or something, and your grandfather says stop and you don't stop, you're in trouble. So believing what authority tells you was evolutionarily adaptive and helped us survive. But like every trait, including how rewarding agency is, including how rewarding altruism is, for every trait, there's a bell curve of how individual people, how much they have that trait. So there are people who are not very concerned with authority, and there are people who are rule followers who are very concerned with authority. And Mother Nature designed us to be different from one another because in societies, that's what helped us survive the best. If everybody were the same, everybody was conservative versus everyone were liberal, and we can talk a little bit more about what that means neurologically. Everybody was authority oriented, or everybody was authority be darned, we would not have survived as much. So one of the main things evolution did that made humans so successful is it distributed traits among members of a community, because we were more successful with difference than we were with uniformity. So to talk about the malleability of the brain and what is rewarding, I'm using this example of anorexia. This is a functional MRI study where parts of the brain light up depending on what you're doing. And in this particular experiment, people with anorexia in the scanner were asked to think about going without food. And it turns out that the part of their brain that lit up was the same part that people without anorexia light up when they think about food. So that is about as 180-degree difference and flexibility of your brain in terms of what's rewarding. In people with anorexia, going without food was rewarding. Now that sounds so contrary to what I said about the reward system is there to teach you what you need to survive, but it's an extreme example of how different something can be in terms of how rewarding it is if you're in a pathologic circumstances like that particular disorder. To talk about social interventions and this concept of gullibility, let's talk about cats. So you know that in the Middle Ages, cats were revered. They were considered deities. They were buried with the pharaohs and so on. They were, made into statues that people worshiped. So cats were considered really good. And in part, that was thought to be because the cats kept the rats at a minimum in the granaries. And so they were socially useful and revered. In the Middle Ages in Europe, the big event in town that all the kids would run to, and it would be like, like we have 4th of July, they're all going to run to the, where the fireworks are or whatever, the bandstand or, the arcade games, whatever they're going to think is the big community event. In the Middle Ages, they would run to the middle of town where cats were held by their tails on ropes and dipped into fires until they died eventually, and they were tortured. And how could kids think this was rewarding? How could the whole community turn out and applaud and cheer and think this was great? It was because the religious leaders during the Middle Ages in Europe taught people that the devil lived in cats. And if you tortured cats, you were torturing the devil. And so something that most of you, I think, would find horrifying was actually considered fun and rewarding. So these two examples show you as sort of extreme illustrations of how malleable what your brain thinks is rewarding can be, either because of biologic changes or because of cultural changes. So let's get back to climate change. With this knowledge in mind, what can we do? This IPCC curve from 2021, this is showing not temperature, but carbon dioxide levels. And again, same idea. We need to make choices that keep us on these better paths instead of choices that keep us on these destructive and potentially synergistic paths that we can't get out of and can't survive as a species. And there are lots of people out there who think that we just have to wait for the right invention. We just have to wait for the right battery or the right alternate fuel source or nuclear fission or fusion or, solar geoengineering. We just have to wait for the right tech fix. But we don't have time to wait for the next. All those tech fixes may come in handy and may in fact bend this curve. But the general feeling among most people that I talk to is that before we get that big fix, because things are still happening so fast right now, before technology bails us out, we need to so-called flatten the curve. Now, flatten the curve is an expression that came up in the pandemic. We knew we couldn't get rid of the pandemic, but what we did, how we behaved, how we treated it, how we isolated, all those things that some people didn't like, would keep it to a minimum until vaccines came around, until new treatments came around. And we're in the same situation now. So what do we need to do? We have to stop fossil fuel and greenhouse gas consumption and waste and pollution, as you all know. We need to level and redistribute population growth. That's that other curve. We have to address land use and biodiversity. Again, you folks all know this. And we have to adapt to climate change effects equitably, because we're really, at least in our country and around the world in many ways, the haves and the have-nots, and we need to do it more fairly. So how do we overcome this more idea at the level of a corporation and an industry, at the level of an institution like academic institutions, at the level of governments? Is a growth economy the only kind? We have all been socialized to think that if you're in a university like I am, if you're not constructing and building new buildings onto your hospital or your college campus or whatever, like, you're behind. You have to get bigger and bigger and bigger. If you're a company, you have to get bigger and bigger and bigger. This idea of a growth economy, it turns out, as many of you probably know, it's just one model, but it's a model we have bought into as though there is no alternative. And it's a model that continues to fuel this more idea about climate change. So, what behaviors work best for difficult behavior change in general? So, let's sum up to here. Our brain is predisposed, but not inflexibly hardwired to go along with this idea of more consumption, more growth, and we, as a consequence of that, have this real hard problem of climate change that's hard for us to perceive and think is our shift. Now, when I say us, I again don't mean people in this audience, I mean people around the world. So how do we change that? How do we change those utility calculations that our brains are making? In order to try to answer that, I wanted to look at difficult behavior change in general, not about climate change, but about difficult behavior. And I wanted to look at two things. One, a personal behavior change, and another, a social behavior change. So the two examples I studied were addiction, which is about the hardest and most intractable individual behavior change, and the Ebola epidemic in West Africa that started in 2014, because that required social change. And I'm not going to go into all the details, but what I'm going to say is that there are certain principles that these difficult behavior changes have in common in terms of what works. Number one, positive works better than negative. Punishment does work, but giving people something positive, and again, this is why I think this vision of the future is so important for people in the climate movement, giving people something positive and a vision to work towards is better than doom and gloom. I'm not saying doom and gloom doesn't work for some people, but in general, in behavior change, positive is more effective than negative. Information has to come from people you trust. So what's part of the climate change problem? People don't understand it. When I say people, I mean the general public. They don't have the background, and the information comes from talking heads whom they don't know personally, by and large. People on TV, people who say stuff, they don't understand it, and they don't know these people and don't necessarily trust them. We'll get into how to deal with that in a moment. You get a substitute reward that's immediate and tangible. So what that means is you can't just take things away, like the vegetarian diet that feels like you're telling me I can't have meat. You have to substitute something that is immediate and also rewarding. That's the basic principle of 12-step programs in addiction, that you take away things that, the addictive circumstances, but they get a powerful social reward as the alternative. You have a group, you give public disclosure, people support you, they try to come up with alternative things for you to do. And so the substitute reward is the next bullet point, which is social rewards, which are one of the most powerful human rewards. We talked about agency, we talked about acquisition, but social rewards are incredibly powerful. We'll get into that again in a couple of minutes. We're almost at the end here, I promise you. Making a public commitment is a really important thing in addiction, like saying, I take ownership for this. It was also important for the Ebola epidemic, where expertise came from community leaders, people that people in the community trusted, religious leaders, and they had public things where they said doing it this way instead of that way is acceptable and okay. We can talk more about the Ebola epidemic. It's a very, very interesting story, but we don't have time to go into it in detail. So now let's take those pro-environmental principles and apply them. Those behavior change principles, and apply them to pro-environmental behavior. There's less data on this than in behavior change in general. But again, same principle, change has to be more rewarding than the alternative. So in climate change behavior, the idea is people can do things differently and not do without. So it's, instead of curtailment, it's substitution. So for example, in the health community, when you walk instead of drive, when you take public transportation, when you switch to renewable energy, all of these have health co-benefits. So when you get rid of your gas stove and put in an electric stove, like, your indoor air quality is better. When you walk or take a bike, your cardiovascular health gets better. So one of the things in the healthcare community has been to, for lack of a better word, promote pro-environmental behavior, because most pro-environmental behavior, switching your diet to get rid of a lot of your red meat, it's healthy. And so you can appeal to people's self-interest with the health co-benefits, or the health co-benefits for their community, and their children. You can try to find ways to give financial incentives. This is what most of us are worried about because of the election, because the financial incentives came from legislation, things like the Inflation Reduction Act, things like the CHIPS Act. So there were financial incentives, either from the central government or local governments. And luckily, the local governments we can still count on. Changing codes and regulations so that there's penalties for going the other way. The Joint Commission is an accreditation thing for hospitals. It is starting to require, now it's voluntary, but we're hoping that it'll become mandatory, that hospitals report not only on their health outcomes, but on some of their sustainability. When you put a grant into the National Institutes of Health, there is now a section that says, tell us how you're going to minimize the environmental harms done by your research project. And then things like laws, the Environmental Defense Fund, the Conservation Law Foundation, lawsuits are financial incentives to not break the rules. And public pressure campaigns also put incentives on institutions like hospitals. When we get public pressure campaigns from advocates, they want to look good to the general public. So if the general public cares about this, those public pressure campaigns can move the needle. Then there's a principle called honeybee rewards. This is the Ford F-150 Lightning, the first Ford electric truck for mass production. And when they brought this out and rolled this out, they did not advertise it as the tree hugger truck. They advertised it at car crushing competitions where it could crush cars way better than internal combustion engines because the torque was so high. And so this is what's called a honeybee reward. We're not going to try to make you get this truck because you're environmental. We're going to try to give it to you because it's more powerful. And we're going to call it the Lightning, not the Eco Truck. And the idea there is that the honeybee doesn't go around in order to pollinate the flowers. It goes around to get nectar. But in doing so, it also pollinates the flowers. So the electric truck is better for the environment, but that's not what the people buying it, by and large, are caring about. So that's embedding the environmental thing as a honeybee reward. But then the other huge strategy that your organization already uses is social rewards from like-minded people. So within your organization, that works great. But if you happen to be also a CEO or on a board of a business, and you want to make this pro-environmental change, you will benefit from having 5 other CEOs of other businesses that all make this change together, and you reinforce each other. If you're an institutional leader, if you're in a profession, if you're on the alumni committee of your college, whatever, social rewards from like-minded people can really help to incentivize these changes when otherwise you feel like you're dangling out there by yourself. So the bottom line is what's rewarding can be changed. This is a 4-month-old baby who already knows how to swipe a touchscreen. That's hugely rewarding. You take that away, the kid cries more than they used to when you took away a book or a stuffed animal when you were examining them in the office. So this is not inherently rewarding. This became rewarding when this environment changed. Similarly, as climate change gets worse and worse and those CO2 levels go up and we just are, sick to our stomach when we see smokestacks, the utility calculations that we and others will make will shift. So you wanted a Hummer, you might get a Rivian. You wanted a, sporty car, you might get an electric car. You wanted new clothes. Instead, you might follow the example of the Fashion Institute of Technology, which offers a program in extreme mending, radical mending, they call it. So you take your sweater with holes in it and they'll make it into a piece of art. So that's an example. You want new furniture? Do you really have to get, these enormous, oversized, brand new, not very environmentally friendly things? Or can you go to your local antique or thrift shop and get something one of a kind that looks cool, that also is more environmental friendly? So the point is substitution, not curtailment. And one of the principles that I learned during my exploration is that stuff doesn't even make us happy. Consumption doesn't even make us happy when you define happiness as long-term life satisfaction. Long-term happiness studies following people over decades and half centuries and, beyond, is that there are two things that correlate with life satisfaction, and it's not your material wealth. It's a sense of purpose and it's your relationships, those two things. When you get stuff, you get a very short-term reward, but it's not the same as happiness or long-term life satisfaction. And many of you know this already, I'm sure, at your stage of life. I want to just make one comment on the immense power of the parent-child bond. This is one of my patients and his mother. I have been just gobstruck over my decades of being in this field at the intensity of that bond. And I think it's why most major religions have a parent-child sort of focus in many different kinds of religion. It doesn't mean that you can't have that bond if you don't have your own biologic children, but we're all children of somebody. And that bond is something that we can call on, and I'm sure many of you do, because we really care about and worry about the next generation. And when we're talking about 100-year time frame, that's what we're talking about. And it's powerful. And it's powerful to people who make policy as well. So we'll end up here. The challenge of the three curves, the temperature and climate change curve, the population curve, the pace of change curve. Our challenge is to get over the hump and think long term. We need to make these behavior changes until technology bails us out and even beyond. And it's challenging, but unless we give people a vision for the future, we're going to struggle. So for climate communication, what works? Simple messages, stories with real people, from trusted people that are known and repeated. So what are our mantras? Electrify, then green the grid. You already know this. This is in your town, your public and commercial buildings, your own house, green transportation, and talk it up when these changes are made, because you will have a ripple effect because of the power of social rewards. And you may not even know who you're influencing, but by talking it up, you will have an effect beyond your own influence. Stay up on politics and vote. I know we all are disappointed, or at least I'm going to make the assumption most of the people on this call are disappointed with how things went, but the midterms are around the corner, and we got to stay engaged, and particularly locally. Show up and speak up. When you're a knowledgeable, known person with a trusted voice, you have a lot of power. And you know that there are opportunities for advocacy at many levels. But remember that because the brain is engineered this way, you may not see immediate effects of what you do, and yet you still may have a powerful influence on others and their utility calculations just by your own beliefs and making them public. So the hard facts about pro-environmental behavior change: it won't feel as satisfying as most decisions. It won't pass that gut check. You have little agency and little immediate reward. You won't get much for a pro-environmental decision. You're going to get mostly social rewards from like-minded people if you're lucky. But if you expect that and you understand that, you won't feel so uncertain about making those decisions. It will take changes at every level in your individual lives, your roles in other spheres, making those tough switches to prioritize long-term gains that you may never see. Nonetheless, pro-environmental action and advocacy is still one of the most important things you can do, even if it doesn't feel like it. Even if it doesn't feel like it. My rewards in being a pediatric neurosurgeon were immense, but that doesn't mean they're the most important thing. I think that this work is more important than that, even though it was very important for those individual children and individual families. It's not the big picture and it's not the long term. So we have to have a vision for the future that we can engage others in and be mindful of and be positive about, even when we have setbacks, because positive works better than negative and it's just more effective. So I think that's my last slide. I will stop sharing. And I talked for a long time, so I think we still have time for discussion. Mm-hmm. And I will turn it back to Amy.
Thank you so much. I found it fascinating. And even though I've been committed to this for a long time, it's gotten me to rethink some of the things I've had trouble making changes about because I understand it better. So I really appreciate that. So we have one question in the chat, and I want to encourage people, if you can raise your hand electronically. I see Tina's up there. It's actually easier for me to see that than to read the chat, but I can do both. So I'm going to start with a question from Roger. How do we make long-term life satisfaction the reward that drives short-term choices?
Yeah, well, I don't think you can in terms of your reward system, because that's not what your reward system is designed for. Your reward system is designed for decisions about immediate survival, like a mountain lion's going to jump on you. Like that's what, or you need food. That's what your reward system is for. So the long-term life satisfaction, that requires cognitive override in some ways. And it's a much later evolutionary event. And so you have to know that that's the case and act with those using your conscious decision making. And that's why it's challenging, because this whole thing about climate change, this long term, it's happening somewhere else. And it's also really hard for people to put together 2 and 2 about, I drive a car and that's why there's a storm with a flood, or I, consume a whole bunch of stuff, or my business produces carbon and that's why there's wildfires. Like that cause and effect requires intellectual knowledge. It's not something viscerally connected in the way we perceive things. And so putting those long-term life satisfaction goals and realizing that that's something you have to learn and then pass on to others. It doesn't happen naturally. It doesn't happen intuitively. Not entirely, because it. So sort of many people, the great writers have said this. I mean, that's wisdom, that's knowledge. That's something this group probably has a surplus in. But spreading that around to others, they're going to think you're an old fart if you say to your 20-year-olds who don't, your 20-year-olds care about climate change. Let's say your 45-year-old neighbor who drives 2 SUVs, like saying that doesn't really make you happy. You're going to get pushback. Well, it makes me happy, So that's something you have to show by example, I think.
Can I have just a quick follow-up, Amy, on that?
Sure.
So I'm wondering, it does seem like educating people and trying to engage them and understand what's happening with climate change and doing that in a way that's positive, that in order for that to motivate behavior change, that would require cognitive override, as you described. Should we be trying to learn more about how to make this cognitive override happen and make it be more effective, because the immediate reward problem is, even though there's neuroplasticity, is still really a major challenge?
So, Roger, what I would say is there's no one answer here. And, you have to look at what is your sphere of influence and what works best in your sphere of influence. So positive better than negative. One of the things that many of you probably do is take a young person out into wilderness. It doesn't have to be wilderness like the Grand Tetons, like your backyard. 2 square feet of grass for a toddler is all you need. Give people a love of nature early on, and then teach them about the combination, the association between climate change and nature and decline, so that they're motivated to do something to protect it. That works for some people. For other people, it's going to be economic advantage. And gee, renewable energy, like they're really doing well. Like the stock market is up in renewable energy. Like that might be a good investment for you. For other people, it might be something along the lines of health benefits. Yeah, I know that steak is really good, but like it really increases your cholesterol. And it turns out that you like red meat because cavemen had very little of it, so they really liked it. But it's not actually that it's good for you at this level. So sometimes it's that sort of information. But that's not about climate change, but that's a health benefit. And you don't even have to talk about climate change to have an influence on people about other things that are the honeybee rewards. So it varies from person to person and audience to audience.
Great. Thank you. Tina.
Well, thank you so much. Really interesting, and I appreciate all the work that you've done to think about this big challenge and how we think, how their brains work. So I want to ask about storytelling and how the brain processes language, and how storytelling can be really important in how people make decisions. I'm sure you've read Yuval Noah Harari and his ideas about storytelling. And from my work in public health, all the work that we did on tobacco and how we got big social change and laws changed and behavior change around tobacco, and how we can apply that to this. And is there any similarities?
Yeah, that's a great question, Tita. So there are lots of parallels. I mean, unfortunately, a lot of the parallels is the self-interest of the tobacco companies and the self-interest of the fossil fuel companies, right? And so there's been a lot of exposure of how the techniques of disinformation are absolutely parallel. But with respect to behavior change, it's a little trickier because the behavior change about smoking cessation benefits that individual. It's immediately beneficial to that individual who's stopping smoking. Whereas climate change, the pollution effects are local, the carbon effects are global. So you can sell decreasing fossil fuel combustion to a community by saying that you will have immediate decrease in your particulate pollution locally. So people do benefit from that. And that's been one of the big strategies. But in terms of CO2, nobody is going to notice it immediately if you decrease your CO2 output in a particular locality. So it's a little more challenging than smoking in terms of cause and effect and who gets to benefit, but not totally without parallel.
But if you look at not the smoking behavior, that's one really important piece around the addiction, and how that was addressed successfully for the most part, but also on the selling and marketing of the product, and how
exactly.
And how we market and sell fossil fuels and the lifestyle around it that you were talking about, and the consumer behavior around it. And I think we haven't got to the effectiveness that we had around tobacco around this yet.
I agree. And there, as you probably know, if you're a public health person, there have been efforts to try to get fossil fuel people to advertise. But again, they're not selling usually to individual consumers. They are if, you have oil heat or whatever. But a lot of fossil fuel is sold to municipalities or sold to industries. And so it's been trickier than a product that is sold to individual people and was labeled for individual people, because that's where the health effects were. So I totally agree with you that there are parallels, and there have been movements in the policy side to try to get fossil fuel companies to have to, and that's the social cost of carbon too, like to price that in. That's another approach to the same thing. These have been tried. There's been a lot of pushback, and I see something in the chat about how do you feel about the election? I mean, this is why we're so upset about the election, because there was progress and now there will be backsliding. Can I take out of turn, Kitty? You've been focusing on individual change, but we need behavior change in whole societies. Absolutely. I don't disagree with you. And that's why it's easier to understand about individual change, but individual change in your own life is not the only thing the brain does. And so in the book, throughout the book is the story of, Tina talked about stories, a politician about to vote on a bill about climate change. And it's a theoretic, bill on some big climate change legislation. And it's about how that individual legislator might be influenced to vote on something that has a big impact. So it's not just, when we talk about the brain, it's not just about your brain and your life. It's about the brain of everyone that has to make decisions, whether it's at COP29, whether it's at the US Congress, whether it's at the CEO of or the VP of Exxon. The only place decisions are made are in the human brain, even though that individual can be influenced by other people that are making the decision with them on the board, whatever. All of these decisions that are at institutional levels are made by individuals in that institution. So I don't want to make a differentiation between individual decisions about your own life and decisions made in the brain of people who have big decision-making power in institutions and societies. There is a whole other sort of subtext about societal movement and change within society. Some of that is in the book, and it's absolutely true that things spread. And that's why I say it's so important to speak up, show up and speak up, because you will be part and are part of a movement that influences others. You may not see that influence, but societies and societal change, yes, it's absolutely part of the equation. And I don't want you to get the impression, I don't want to give the impression that behavior change is just at the individual level. It's not. It's at all these different levels. Okay, sorry. Go ahead, Amy. Pick on somebody.
That's great. Thank you. We have less than 10 minutes left, so I'll try to get to everybody, but we may not. So Glenn, you're up next.
Yeah, hi, Tina. Thanks. I've always thought that the humans evolved over a long time period from, let's say hunter-gatherers or small communities, and that walking into a supermarket like Big Y or Stop and Shop is actually, we're actually performing as hunter-gatherers and attracted to all the bright, shiny objects, and that triggers our evolutionary, thousands, hundreds of thousands of years of evolutionary development. And the same thing with technology now that we have before us. It also is very accepted by us because of our evolutionary need for immediate gratification and rewards. And so how can we find a similar anchor in our evolutionary history related specifically to climate change that gives us that same ability to influence individuals and society, cultural evolution based on our long history of evolving toward the, I don't want to say the messed up society that we have, but the ability that certain people or certain things have been able to exploit that kind of deep programming from our evolution to take advantage of. And how can we find that part that we still have deeply buried in us that relates to the climate crisis?
Yep. I don't have a perfect answer, but one of the things that most people that I work with think is critical is to embed the actual cost of carbon into carbon pricing. And this idea of the social cost of carbon, because then what we want would have an evolutionarily logical cost. There are people, like I said, these 15 or 20 journals of consumer behavior. The reason when you go in the supermarket that you're drawn to certain things is people have spent enormous time and effort and money to get you to buy stuff. And they're really, really, really good at it. The fossil fuel companies are really, really good at it. They know what's going to sell. Look at the term, you know this, I'm speaking to the choir, natural gas. Was that a marketing coup? They didn't call it methane. They called it natural gas. That is marketing. That is 100%, 110% marketing. And people are really good at selling you stuff that not only do you not need, but that is bad for you. That's tobacco. That was tobacco, as others have said. So how do we tap into it? We can't. That's the problem. That's why climate change is a disaster. That's why we're not doing it, because it's not rewarding. Now, if you did carbon pricing that took into effect the actual social cost of carbon, people would start making economic decisions, which we're very well designed to do, based on that. But there has been so much pushback from the fossil fuel industry. Now, the idea is that as the public increasingly makes this connection, if they're able to, but honestly, I mean, somebody asked in the chat about this election. In my mind, this election was because most people don't get their information from trusted experts. They don't trust experts. And it's much easier at the end of a long, hard day to watch something that someone is trying to sell you and that you pay for, that they make money off of, whether it's Netflix or sports betting or whatever it is. That is just much more rewarding in the short term than doing boring homework about economic principles and why inflation happened and why it wasn't actually Joe Biden's fault that inflation happened and that it was coming under control, even if you didn't see it yet. That is homework. That is boring. That is dull. And so the American public was pretty uninformed about climate change and policies. And so that's a long answer to say, how do you make it? If there were a simple answer, Glenn, that I could say, here's the switch, let's just do this. No, we got to chip away. We got to use social reward. We got to use our trusted voices. We got to show up, and we just have to keep doing what we're doing, but harder. If I just notice, some of you are from Vermont, but I just noticed when I drive around in my electric car and see the billboards of advertising that I pass, I would say 2 out of 3 of them are for stuff that not only do you not need, but it's bad for you because somebody makes money off of it. And that's part of what we're fighting. That's not a satisfying answer, but where I am. Amy, pick on somebody else.
Okay, I'm going to have one more and then we'll need to stop. So Sue Thomas.
Thank you. I'm sorry my camera's not working today. This has been hugely valuable in pulling a lot of information together for me. I think obviously economic signaling is really important, whether that's through carbon pricing or other methods like valuing our forests and our old growth trees prior to making a decision about cutting them down for other uses. I think you talked about nudges and budges, and I think the climate movement isn't as good about incorporating those signals that people aren't even conscious of when they choose behavior, and that we need to normalize the behavior that we want. And we do that through introducing them to people they trust, whether it's their neighbor who's adopted a new behavior, or whether we reintroduce shaming, which I'm always hesitant to do because it's a negative rather than a positive, but shame is an extraordinarily powerful social influencer in social animals, which we are. And so I'd love your input on staying positive, but also normalizing the good and maybe reintroducing some notion of social boundaries for behavior we'd like to start eliminating. So there is a pain reaction as well as a pleasure one to bad behavior.
Yeah, shaming is kind of useful for some people. And again, I think, Sue, it depends on your audience. Most of the data that I quoted in the book about positive being better than negative comes from education and from certain other narrow contexts. So shaming is good, but in general, if you can make somebody feel positive about what they're doing instead of negative, it just sticks better. It just sticks better. So,
sorry to interrupt. I think that the positive for most people is exposure to nature and getting enough of it so they can understand why it's important. We're so in the screens that, and I think the health community is coming around to expressing those health benefits, mental and physical, through studies. But I think the more we can expose people to the environment where they look at a day like today and go, today is not a normal day, where they have that intuitive response that most people don't have anymore because they've lost that connection.
Yeah, Sue, what I would say is that is absolutely true for some people, but not everybody. So for some people, exposure to nature is the trigger that's going to get them to be pro-environmental and care about it. For other people, it's going to be economic benefit. For other people, it's going to be health benefit. And sometimes they overlap. For other people, it's going to be worry about their kids. So I think that one of the things to keep in mind is everyone is different for a reason. We're different from one another because that works best for us evolutionarily. And so different audiences are going to respond to different things, but absolutely nature is one of the big ones. I think social is another. I want to respond to something Roger asked about why isn't riding a bike agency? Riding a bike is agency if I choose to ride a bike and I ride a bike. That's not what I was talking about. What I was talking about is if you are riding a bike because you're concerned about climate change, you will not get immediate feedback that helped climate change directly through your senses. As opposed to if you're a hunter-gatherer and you find a bunch of nuts or shellfish or fish and you bring them back to your community, you have immediate tangible feedback on cause and effect of what you did. If I'm a surgeon and I take out a tumor and the post-op scan shows that the tumor is gone, I have immediate cause and effect of my behavior. Whereas climate change, when you ride the bike, yes, you have agency that you chose to do it. You don't see the climate change effect. That's my point. So absolutely, you have agency in the context of general, I chose to do it and I did it, but you don't have the cause and effect that it helped climate change other than intellectually. You don't have it directly through your senses.
I know we could probably talk another 2 hours. It's fascinating.
I'm okay. I'm
but
okay
I
if
think-
somebody has one more question, but I'll leave it up
gonna-
to you.
I think we're going to need to stop now.
Too
and
bad.
we are planning to keep working on behavior change as one of the themes of things that we're exploring and presenting. So I know we're going to build on what you've shared today. It's really been comprehensive and really fascinating, and I think we can make good use of it. So I just want to thank you very much. This was a really,
Thank you.
I found it a very rewarding hour and a half.
Yes, indeed. Thank you.
Thank you.
Thanks, everybody. Appreciate it.
Thank you very
Good
much.
luck. Keep the faith.